The Lockheed Martin F-35B is a true masterpiece of engineering. And it's almost certain that we'll never fully understand just how incredible and extremely advanced these fighter jets are. From flying at over 1,900 kilometers per hour to becoming invisible to radar systems and even having active measures to evade missiles. Perhaps the most impressive of them is the unbelievable ability to hover in the air. Hovering in the air like a helicopter. This is the closest humanity has come to creating a transformer. But why create a plane capable of hovering in the air? Well, the answer is simple. To create a plane capable of taking off and landing literally without needing a long runway. All planes suffer from the same problem. To take off, they first need to run along a long runway to gain enough speed to lift off. That's not an issue if there's a runway. But when it comes to military planes that need to operate on an aircraft carrier which have tiny runways, things get complicated. In such operations, these planes need a little push from a catapult, which works very well until the catapult malfunctions. That means the planes can't take off. And this is where the need for an aircraft like the F-35B comes in, which is designated as STOVL, or Short Takeoff Vertical Landing. To begin with, the F-35B has only one engine, the Pratt & Whitney F1-35PW. It delivers a thrust of 191 kN and is capable of propelling the fighter to a maximum speed of 1,970 km/h with afterburner. When the moment comes and with the push of a button, that's when the real magic starts to happen. And a series of things happen very quickly. First, a set of doors in the front open, revealing a lift fan or vertical lift system. This lift fan is a set of two counter-rotating fans mounted horizontally. They expel air at extremely high speeds directly downward. And this engine produces about 50% of the force needed to keep the F-35B hovering. This lift fan is directly connected to the fighter's main engine through a shaft. The rest of the force that keeps the F-35B hovering comes from its main engine. This engine features the three-bearing swivel module, or 3BSM. It has the ability to rotate 95 degrees downward in just 2.5 seconds, and it can produce up to 18,000 pounds of thrust, which translates to something around 8 tons of thrust, coming from the engine directly downward, which allows the F-35B to stay airborne in a hover with the lift fan at the front. But how does that engine back there manage to turn 95 degrees? So, the engineers saw it as a fabulous solution. They split the engine's exhaust duct into 3 asymmetrical parts. These parts are operated by servo motors. So, with just the rotation of these 3 segments, the engine can turn up to 95 degrees. It doesn't end there. This design allows the engine to assume 2 crucial positions. The first one is with the rotation of the central segment, which puts the engine at a 45-degree angle. This configuration is used for takeoffs, dividing the power between forward thrust and upward lift. This allows the F-35B to take off from aircraft carriers that have very short runways. This way, it can take off from runways as short as 258 meters. 258 meters is a very short distance for a fighter jet to take off. For a full hover or even a vertical landing, the final segment rotates and the engine moves to a 90-degree angle. And this is where the F-35B shows its true ability to hover in the air. At this 90-degree angle, the engine can also move slightly to the left or right for fine adjustments, and help keep the aircraft balanced while hovering. And that's why in some videos you can see the engine moving quickly to make these fine adjustments. But both the lift fan in the front and the engine in the back are just holding the weight of the plane. And if the fighter wants to turn and bring the front to the back, or vice versa, how does it do that? For that, There are small air outlets located on the wings, with air bled from the engine. These high-speed air outlets ensure control of the aircraft and also allow the pilot to make small movements while the plane is hovering. Remember that all these systems are completely controlled by several onboard computers in the fighter jet. No pilot command is executed without first being analyzed by a handful of computers. With all these systems, the F-35B is much more stable compared to its predecessor, the Harrier. And speaking of computers, the transition from horizontal flight, that is forward flight, to hovering takes only 15 seconds. And all the pilot needs to do is simply press a button, the stow veil. The computers then reconfigure the entire fighter jet for hovering flight. Now that's an extremely advanced fighter jet. But not everything is perfect. The F-35B has some serious disadvantages. The lift fan weighs 1.2 tons, a huge weight that serves no purpose during flight. And it also requires more fuel and more engine power to carry it. But it doesn't end there. In other versions of the fighter jet, that area holds extra fuel, which means that the F-35B's range is heavily affected. And I think I don't even need to say that the designers of the lift fan had to work real magic and make a lot of simplifications to make this whole system extremely lightweight. And that's why it only weighs 1.2 tons. In addition to more expensive specialized maintenance. Imagine if one of those doors fails to open on time. But just like in all of aviation, all these critical systems have redundancy. So the probability of a failure in one of them is very low. And that's basically how an F-35B is able to hover in the air.